Tried to do the whole, you are getting very sleepy. I've done any of that.
That's been working though.
Or have you?
It's been worse every time I get home.
It's not that big. I tried to do a good job.
It's still the last half of 6, 7 here. So we've been saying this all along. If 2 is the 0, what was its term?
-2.
X minus 2.
Well, same thing.
The term would have been x minus 2. Now, if your 0 was, ladies, please. The 0 was -6. What was your term?
X plus
Plus 6, and so on. So what we're doing here is that we're finding terms by taking x minus whatever the 0 was. You agree? Okay. So here's where things get interesting then. We're going to write out a polynomial of least degree that has real coefficients given the zeros, blah, blah, blah. So if I have zeros of 3, 0, and -2, what would be my 3 terms?
X minus 3, x plus 2, and x squared. Or x. It wouldn't be x squared, never mind.
And it would be x. Those would be my 3 terms. To write the polynomial out, then, what would I do? Foil it, multiply out. So when you foil out, oops, you get x squared minus x minus 6, and then I have to distribute that last x term. So I would get x cubed minus x squared minus 6x would be the polynomial that has those 3 zeros.
That's it?
No, there's
Beans.
Oh,
Yeah. You're always hiding something.
Challenge accepted, bro.
Wait, what is he?
Now,
Is that an I and negative I?
it is. Because if you've got one imaginary term, you have to have the other imaginary term.
Plus minus.
Okay? What happens here, what happens when you start throwing in the I values? When you start throwing in I values, if they list just one of them, which says I, negative I has to occur as well. Because the only way you can get an I value would be like I squared or x squared plus something. Okay?
So isn't the negative
So
I
it'd be
just
x
one?
squared plus 1.
Hold on. We walk through it here. We do the same. We're going to do this kind of like the same idea here. When you have 1 as a 0, what's its term?
X minus.
But I have 2 of them, so I have x minus 1, x minus 1. Now I'm going to show you guys long form of why this is going to work. When you go long form here, we're still going to say it's x minus I and x plus an I. You agree on that? Now, when I multiply that out, I'm just going to show how it works with the foiling of the I value first. When I foil out the I value, I get x squared minus I squared. What was I squared?
Negative 1.
1.
So I get x squared minus a negative 1, which is x squared plus 1. Okay. I'm still subtracting the 0 term, x minus the 0. Okay. The other part was the x minus 1, where we would get, what does that work out to be? X squared minus 2x plus 1. And you'd have to multiply those 2 terms together then. I just foiled that.
Wait, where'd you put that down?
Oh.
So I'm just cleaning this so you can see where I'm going here.
Thanks.
What I did here, I got this as x squared minus 2x plus 1. I foiled this out, got x squared plus 1. But then again, at some point in time, you might actually recognize that if it's an I value, it's just plus minus I, that came from x squared plus 1. It'll become a little bit crazier when we start throwing in other values with the i's. We'll get there. So you just multiply these 2 together. So if you had 4 zeros, you're going to have a 4th degree polynomial, x to the 4th, and so on. So you get x to the 4th minus 2x cubed plus x squared plus x squared minus 2x plus 1 will let you.
Sweet.
And there's your polynomial function.
You have to put after that.
I'm not going to yell at you.
Wait, what?
And the instructions is write the polynomial with the degree. Well, there's the polynomial.
Okay.
The kicker is going to come in that you're going to forget that there's a plus and a minus. Let me show you the last. And this is where it can get really nutty. So my zeros that are given are 5 and 2 plus 3i. Now, if there's a 2 plus 3i, what else should there be?
2 minus 3.
There should also be a 2 minus 3i. So whenever you see this as just one part, there automatically has to be the other one. Because the only way you can get i's is if there was an I, if it was something squared. You okay with that?
Yeah. Okay.
So here's what happens. First one's easy. It's x minus 5. The second one, we have x minus, what's the quantity? 2 plus 3i. And then it's the other one is x minus 2 minus 3i. Remember, I'm just subtracting that 0, just like we have that. Just so happens that this 0 has 2 parts to it. Okay. So inside, excuse me, inside here, I'm going to do my same change opposites, distribute the negative, and I get x minus 2 minus 3i. Here I have x minus 2 plus 3i. You okay with that? Here's the weird part. Put those front two with a little bracket around them. And you're going to FOIL it like you would normal. First, so I get x minus 2 quantity squared. But take a look at what happens. Isn't this the same as saying a minus b, a plus b?
Sure.
Wouldn't that work itself out to be a difference of squares? One of the ways people have shown this is something called U substitution. Basically what that means is you're letting something simple equal something complicated. You use this in calculus all the time. So I'm going to say let, just so you can get the idea of what I'm doing here, let A equal x minus 2, and I'm going to let B equal 3i. You don't have to show this step because after I show you what exactly is going on, you're going to pick up on it pretty quick. But just in case you want to fall back on a surefire way of making it work, this isn't a bad idea. So before I come back into here, I'm going to rewrite this as a minus b, a plus b. Because in essence, that's what I have right now. If you FOIL that out, what do you get? A squared minus b squared. So you get a squared minus b squared. Well, what was a?
X minus 2.
So this becomes the quantity x minus 2 squared minus the quantity 3i squared.
Interesting.
FOIL out the x minus 2. X squared minus 4x plus 4. Now you have to use your power of exponents. 3i quantity squared, which means I have to square both the 3 and the I. And what's I squared? What's 3 squared? So this becomes x squared minus 4x plus 4 plus 9.
I know.
That was too bad.
It just looks weird. It's this step right here by distributing out the negatives that most people get tied up on. But once you get past the idea of just distributing out the negative to rewriting it as a difference of squares, that's how it's going to work. Okay. So you wind up, we still have that x minus 5 up there. We wind up still having to multiply all this by x minus 5. Yeah, it'll be a plus 13 here. So it'll be x minus 5, x squared minus 4x plus 13. And we'll get x cubed minus 4x squared, plus 13x minus 5x squared plus 20x minus 65. And there's your polynomial. The weirdest part is going to be distributing out that piece. And it just takes a little practice. Okay? Let's try another one. Holding. All right, here we go. Let's say those are the two zeros they give you. They give you I and 2 minus I. Well, if they give you I, what else has to be there? Negative I. So that means right off the bat, we know that this is going to be a plus minus I. And we know what that term is, right? What's plus minus I going to give you? What will be the term?
1 squared. I don't know.
X squared plus 1 is what I was looking for. The term that gives you the I values as zeros is always going to be x squared plus 1. That has to be.
Okay.
That one's easy once you see that one. The other one, remember, if you have 2 minus I, you have to have 2 plus I. So you write it out. You have x minus 2 minus I. Oops, got my parentheses. X minus 2 plus I. Distribute the negative and rewrite. That way I can put this part in brackets to make it show that I'm getting the difference of squares. So really all you have to do at this point then is square that first term, subtract squaring the second term. So we get x squared minus 4x plus 4 minus I squared. And what's I squared? So 4 minus I squared is 5. So you get 4 minus negative 1, so you get 5. So you wind up with x squared plus 1, x squared minus 4x plus 5. And then you just multiply it out. Remember, the trick here, guys, is when you're writing it out in terms of the i's, is that there's always going to be, if there's one of them, there has to be the other one. Okay? There's always going to be, if there's a plus, there's going to be a minus. If there's a minus, there's going to be a plus. And once you get it written out this, it should always look like a difference of squares. A squared minus b squared. It'll always work like that. It's kind of a nice little trick to remember. Yeah. Pre-calc, we actually do stuff with, we'll do that. It's really not that bad. You do the same thing. there's 2 minus root 3, there has to be a 2 plus root 3. So you'd have x minus 2 minus root 3 and x plus, bless you. And you would do the same idea. It still works out. Okay. So why not? If you have a 0 of 2 minus root 3, there has to be a match 1. So there has to be a 2 plus root 3. And I'll show you what'll happen is you'll wind up doing the exact same thing. When you distribute out, you get your x minus 2. Oops. X minus 2, this one becomes plus root 3. The other one I get x minus 2 minus root 3. Bless you. And you see how it patterns itself through? Yes, ma'am.
Why do you typically have to distribute the difference? Because I know that the exact same values.
Yeah.
What do you mean?
Because X minus 4, so they're just like, you know what I mean?
I see what you're saying. Yes, what we're doing here is we're setting it up is the generic rule. The generic rule is to get, if you have a 0, it's always x minus the 0 is the term. So if the 0 is 2 minus root 3, that means the term is x minus 2 minus root 3, so it is that x minus 2 plus root 3. It's the same idea. Why are we're actually distributing the negative when we do minus and negative 2. If the 0 was negative 2, you knew it was x minus the negative 2, you would just write it as plus 2. You're doing the same thing. It just looks different, that's all. So if I gave you one with the root, though,
Well, I'm just saying, like, if you forgot to distribute this, you would end up with the same thing because you have the same value.
it's still kind of works. But don't forget.
It's just a positive habit.
I know. Yeah, it's a positive habit. So if you FOIL it out, you wind up, our x squared minus 4x plus 4. And what's root 3 times root 3? 3. Then it becomes minus 3. And then we go through there. Let me give you some of these to try for tonight. I got some 6, 7. Oh, wow.
I know, I'm just.
Another thing will happen.
Yeah, because we've done all the ones in the book already.
No, I love this.
Today was just not been able to. I woke up
Here.
late.
On this one here,
My eyeliner was not working out today.
so on the 6, 7, let's do 19 through 29.
Odds.
All right?
No,
Yeah, because we didn't get, the other stuff was already has some earlier about it. All right? So I've got 5 of them that you guys are writing the polynomials. It's got all the imaginaries thrown in there. Get your practice on it. And then some more of the find all zeros. Okay? And you'll have to do that on a separate sheet of paper because there's no space. Yeah.
If I struggle, I struggle.
And I know there's a whole bunch of extra ones that went back.